All. In this video, we will learn about mobility. In conclusion, students will be able to explain the concept of mobility.
Mobility. A wireless embedded network in such an application may be used in several ways, including to track the forklift itself, the goods being moved, and personnel at the plant. All of these uses of the wireless network require us to deal with node mobility between edge routers in the same LoWPAN, between LoWPANs, and possibly between network domains. At the same time, active data flows may be in progress and application servers may need to know how to reach track device. This section considers what causes different kinds of mobility and how IPv6 and LoWPAN can deal with mobility. Mobility types. Mobility in IP network technically is the act of a node changing its topological point of attachment. Roaming, a process in which a mobile node moves from one network to another, typically with no existing packet streams. Handover, a process in which a mobile node disconnects from its existing point of attachment and attaches itself to a new point of attachment. Handover may include operation at specific link layer as well as at the IP layer in order for the mobile node to be able to communicate again. One or more application packet streams typically accompany the mobile node as it undergoes handover. Mobility can alternatively be described with the term micromobility and macromobility. Micromobility refers to mobility that occurs within a network domain. In 6LoWPAN, we can consider micromobility to refer to the mobility of a node within a LoWPAN where the IPv6 prefix does not change, which is the definition used here. Macromobility, on the other hand, refers to mobility between networks. In 6LoWPAN, we consider macromobility to refer to mobility between LoWPAN in which the IPv6 prefix changes. In relation to the previously defined term, we can consider micromobility to require only handover, whereas macromobility is as a process of roaming and handover. The figure illustrates that forms of mobility with regard to 6LoWPAN. The process of node 1 moving its point of attachment from one edge router to another within the same extended LoWPAN is clearly a case of micromobility. The IPv6 address of the node remains the same, and to the remote server it seems that nothing has changed. In contrast, when node 2 moves from the server, it seems that nothing has changed. Extended LoWPAN to a different LoWPAN, it is roaming to a network with a different IPv6 prefix. Therefore, the IPv6 address of the node will change as well. The case of topology change can be categorized simply as physical movement, radio channel changes, network performance, sleep schedule, and node failure. First one is physical movement. The most evident reason for mobility is when nodes in a network physically move in relation to each other, which changes the wireless connectivity between pairs of nodes. This may cause nodes to change their point of attachment. Radio channel. Changes in the environment cause changes in radio propagation, called fading. These changes often require topology change even without physical movement, especially with simple radio technology. Network performance. Packet loss and delay on wireless network may be caused by poor signal strength, collisions, overload channel capacity, or node congestion. High packet loss may cause a node to change its point of attachment. Next is sleep schedule. Especially battery power nodes in wireless embedded network use aggressive sleep schedules in order to save battery power. If a node finds itself attached to a sleeping router without a suitable duty cycle for the application, this may cause the node to move to a better point of attachment. Next is node failure. Autonomous wireless nodes tend to be prone to failure, for example, due to battery depletion. The failure of a router causes a topology change for node using it as their default router. The mobility of node on the Internet can be dealt with at the network layer using a protocol called Mobile IP, which was originally designed for IPv4. Later, an updated version was developed for use with IPv6 called Mobile IPv6. This new version takes advantage of IPv6 mechanisms and provides route optimization. The goal of Mobile IP is to deal with the mobility roaming problem by allowing a host to be contacted using a well-known IP address regardless of its location on the Internet. Mobile IP does this using the concept of a home address, which is associated with a host home network. When a host is always from its home network and attached to another network domain called the visitor network, the new IP address it configured there is called its care of address. A node communicating with a mobile node roaming in a visitor network is called the correspondent node. The concept of 6LoWPAN is for very simple IPv6 nodes to be able to participate in IPv6 networks over low power, low bandwidth wireless link. Normally, forwarding in IP network is handled only by routers whose route table are maintained by routing protocol. Mobile IP works using a special kind of routing functionality which is host control. This concept is called a binding and is implemented by an entity called the home agent. A home agent must be present in the home network domain of a mobile node in order to use mobile IP. The home agent is responsible for maintaining a binding between a node's permanent home address and the temporary care of address used while roaming in a visited home network. The home agent then acts as a forwarder or traffic destined to and coming from the mobile node while roaming. A good analogy is that of the post office temporarily forwarding mail to a new address when someone moves. The figure illustrates basic mobile IPv6 functionality. When a mobile node roams to visit network, it uses mobile IPv6 in the following way to maintain global connectivity via its home address. After detecting that the subnet has changed and that the node is no longer in its home network, it sends a mobile IPv6 binding update message to its home agent. If the node doesn't know the location of its home agent or its home prefix, there are methods to discover both. The binding update is acknowledged by the home agent with a binding acknowledgement. This message must be secured using IP section methods. Detecting that the subnet has changed and that the node is no longer in its home network, it sends a mobile IPv6 binding update message to its home agent. If the node doesn't know the location of the home agent or its home prefix, there are methods to discover both. The binding updates is acknowledged by the home agent with a binding acknowledgement. This message must be secured using IPv6 method. A bidirectional IPv6 channel is then set up between the home agent and mobile node for exchanging data packets. When an incoming packet arrives from a corresponding node to the home address of a mobile node at its home network, it is intercepted by the home agent using an ND-proxy technique. The packet is then encapsulated in another IPv6 header with the destination address set to the mobile node's care of address. Proxy home agent is an entity which performs mobile IPv6 functions on behalf of a local mobile node, interacts with the actual home agent of the node, and handles route optimization on its behalf. This greatly simplifies the function that a mobile node needs to perform to participate in mobile IPv6 in 6LoWPAN. This is an especially critical optimization as seen from the previous section. A global architecture for proxy home agent is described where proxy home agent functionality is described. The proxy home agent is located in the visitor network where a mobile node is roaming. In 6LoWPAN, this would logically be the 6LoWPAN edge router. A proxy home agent acts like a normal mobile IPv6 host but additionally performs binding updates, home agent tunneling, and route optimization on behalf of other nodes. In order for a mobile node to use a proxy home agent, it simply needs to perform a local binding updates with credential and to create a single tunnel to the proxy home agent. The proxy home agent is located in the visitor network where a mobile node is roaming. In 6LoWPAN, this would logically be the LoWPAN edge router. A proxy home agent acts like a normal mobile IPv6 host but additionally performs binding updates, home agent tunneling, and route optimization on behalf of other nodes. In order for a mobile node to use proxy home agent, it simply needs to perform a local binding updates with credentials and to create a single channel to the proxy home agent. The proxy home agent architecture is shown in the figure. This provides huge improvement in efficiency with regards to security association and for route optimization, which require tunnels and other steps for very correspondent node. In order to use the proxy home agent concept with 6LoWPAN, a mechanism for registering with the proxy home agent would need to be defined for user inside the LoWPAN. The logical place to do this would be as an option for the LoWPAN node registration message. Such an option would need to include the home agent's address or home age prefix, the node's home address, and other credentials. As the tunnel is located between LoWPAN edge router and LoWPAN node, it would be realized as a simple IPv6 extension header option with very low overhead.